we've got 3, 14, and 7 gives us 20 managers. Operatives, we've got 1 and 9 gives us 10, and 15 gives us 25, which gives us the marginal frequencies in relation to the individual levels of measurement associated with job role. And then finally, what we're going to do is for the columns, in relation to the type of car, we're going to sum these up. So we have 20, 23, 24, we've got 24 Mercedes, we've got 29 BMWs, and we've got 27 Volkswagens. In total, for this particular table, the total, either we sum up the row or we sum up the column. In total, you can probably see here that we have 30, 50, 70, we have 80 observations. We have 80 observations in total. Okay, so what we need to do now is construct the expected frequencies. So the expected frequencies, expected frequency table. Once again, we have our execs, we have our managers, we have our operatives, we have, you either drive a Merc, you drive a BMW, or you drive a Volkswagen. And let's just build that particular table. Okay, and we have our columns. So what we need is the expected frequencies. Now, in a previous video, I've done the chi-squared analysis. So what I'm going to do is I'm just going to do these particular individual calculations. For each cell, we're going to take away, we're going to calculate for each cell the observed minus the expected divided by the expected. Sorry, the observed minus the expected squared divided by the expected. So for cell one here, the exec and Merc, the expected frequency would be the row total, which is 35, multiplied by the column total, which is 24, divided by the total, which is 80. So it's 35 times 24 by 80. So you can see that each expected frequency is the product of the row that's on times the column that's on, divided by the total number of observations. So in this case here, we have 35 times 24. So we have 35 times 24 divided by 80 gives us an expected frequency. We would expect to observe 10.5 observations in there. In relation to BMW, don't forget that's on the first row, second column, so it's 35 times 29, so it's 35 times 29 divided by 80. That gives us a value of, we'd expect to see probably about 12, let's say it's 1 decimal, 12.7 observations in there. And in relation to the Volkswagen, it's 35 times 27, 35 times 27 divided by 80. That gives us a total of, we'd expect to see 11.8 observations in there. We've actually seen 5, 10, and 20. So you can see there's differences between what we've observed and what we'd expect to happen. Moving along, we have the second row, first column. So second row is 20, first column is 24. So it's 20 times 24 divided by the total, which is 80, which gives us, we'd expect to see 6 in there. The next cell is second row, second column. So it's the second row, 20 times 29. So it's 20 times 29 divided by 80. Gives us a value of 7.3. Then we have this value in here, second row, third column, 20 times 27, 20 times 27 divided by 80, gives us a value of approximately 6.8. And then what we have here is this, the third row, first column, so third row is 25, first column is 24, so it's 25 times 24 divided by 80, gives us a value of 7.5. And don't forget, we're calculating Cramer's V correlation coefficient. The next cell is on the third row, second column. So third row is 25, second column is 29, so it's 35. So it's 25 times 29 divided by 80 gives us a value of about 9.1. And finally, we have the third row, third column, 25 times 27, 25 times 27 divided by 80 is going to give us a value of 8.4. Okay? So now what we need to do is we need to find the differences between the observed and the expected. Okay, so we need to calculate those particular differences. So let me just maybe fold this over here a little bit so that we actually have it on this, also on this particular page, so we can see both sets. So now what we need to do is, don't forget, we need to calculate the observed minus the expected squared divided by the expected for each cell. So now our chi-squared observations are our chi-squared values. Okay, so our chi-squared, once again, we have exec, we have manager, we have operative, and we have you drive a Merc, you drive a BMW, you drive a Volkswagen, and then what we're going to have is we're going to have in each one of these cells, in each cell, we're going to have an observed minus an expected squared divided by an expected. Okay? So the first cell here is the observed, which is 20, minus the expected, which is 10.5, which gives us a value of 9.5. So we have 9.5 to be squared, divided by the expected, which is 10.5. So divide that by 10.5, which gives us a value of 8.6. Okay, rounding this is about 8.6. Then what we have, the next cell is the observed, which is 10 minus 12.7 gives us 2.7, which needs to be squared, and that needs to be divided by the expected, which is 12.7, which gives us a value of 0.6. Okay, I'm rounding here. The next cell is the observed, which is 5, the expected is 11.8, so we have 5 minus 11.8, and we just square that, and divided by the expected, which is 11.8, which gives us a value of approximately 3.9. It's 3.9 here. Then we have the next cell, which is the managers that drive the Merc. The observed is 3. The expected is 6. So 3 minus 6 gives us 3. When we square that, gives us 9. 9 divided by the expected, which is 6, gives us a value of 1.5. The next one is the observed is 10. The expected is 7.3. So we have 10 minus 7. 10 minus 7.3 is going to give us 2.7. 2.7 squared gives us a value, and it's to be divided by the expected, which is 7.3. So we have to divide that then by 7.3, which gives us a value of 0.99, which is about 1.0. And then we have the observed for this cell. The observed is 7, the expected is 6.8, so that gives us 0.2, and 0.2 squared is 0.04.